After the uniform discrete probability distribution, the next specific and most useful is the binomial. The important properties of a binomial distribution. In n independent trials, there are only two possible outcomes, and the probability of a success or a failure does not change from trial to trial. And the trials are independent. Our interest is in the number of successes occurring in the n trials. So we will let x denote our variable, the number of successes. A binomial distribution can be described with a formula. While it looks complicated, it isn't really. The first part of the formula should look familiar. It's the formula for combinations, and the three variables we need in this formula are n, the number of trials, x, the number of successes of interest, and the prior probability, p. We can best explain binomials with a practical example. Consider an electronics store or any business where turnover or employee attrition is an important problem. Through these next few slides, we walk through the logic of inputs to the formula. We know that P is the probability of any one employee leaving. So the probability of one employee leaving on the trial of the first trial, but not on the second and third, is given by the following. With this logic, we come up with a probability of the three different possible outcomes, each one with a probability of 0.081. And remembering from chapter 4 that we will sum all possible outcomes to get the total probability of 0.243 that one employee will leave out of a trial of n equals 3. Solving the same problem using the probability formula, we get the same result, 0.243. Another way to look at this problem would be the use of a tree diagram. With a simple problem, this works, but for much more complicated problems, it isn't so practical. In most cases, we don't even need the formula to solve a binomial problem. Statisticians have developed tables that give the probabilities for the given values of p, n, and x. In addition, Excel has a simple function, binom.dist, that does. The binomial table looks like this, with probability P across the top, values of n on the left side, and for each value of n, the probabilities of the different values of x. As with any probability distribution, we can calculate the expected value, or the mean, the variance, and the standard deviation. Remember these because we will use them again in Chapter 6. And for our example, here we've calculated those values.